Hey guys, welcome. Thank you for joining. This is the Oracle Autonomous Database Learning Lounge. I'm Marcos Senasibia, a part of the product management team for Autonomous Database. And today we have a very interesting session on how to actually manage a large number of databases, right? So how to understand how to migrate those databases into Autonomous Database and actually work with a tool called the Oracle Estate Explorer to show you, a good visualization of what the database resources and consumptions, right, you have. But also using the new elastic resource pools with Autonomous Database to actually achieve that consolidation and bigger savings as well. So for the agenda today, we have Simon Griffith, Vice President of Cloud Solution Architecture, and Paul Brankin, Cloud Solution Architect. And they're going to share with you guys, how to use the elastic resource pools, right? And how that has made the Autonomous Database Serverless the ideal target for actually database consolidation, right? But also, they're going to help you identify the best candidates because that is sometimes not easy. So they're going to introduce us to the Oracle Estate Explorer tool, which actually is a very lightweight tool that analyzes, hundreds, even thousands of databases and help you identify those databases that will actually have the greatest return of investment, right, on the move to Autonomous Database. All right, so before we begin, basically, please make sure to make sure that you guys type your questions in Q&A, okay? So that's going to be where we're going to be able to reply, and all the folks are going to see those questions and reply to you. We're going to share links using chat, right? So you're going to see that. And then at the end of the session, after a few days, we're going to have the recording available, so you guys can be, can check the recordings as in our main blog post there. Okay. All right, before we begin, just wanted to share with you guys some links that are the most interesting or useful links for Autonomous Database, right? So in chat, I'm going to post these links there, just so that you guys have it. So these are all the links that I'm showing here in the slide. Simon and Paul, thank you very much for joining us and doing this session with us today. And I'll stop sharing my screen and I'll let you start sharing yours and take it away.
Hi, everybody. And thank you very much, Marcos, for introducing us. And today, we're going to talk about a topic which I think is close to everybody's heart now within the Autonomous Database community, which is about moving away from looking at Autonomous Database service as a target for individual databases and looking at it much more as a target for hundreds or thousands of databases. We're all sort of familiar with the main advantages of Autonomous, and you as customers would probably recognize most of these. It's really about moving from managing databases down at the technical level to purchasing that high-level service which has built-in security, performance, and resilience. And because of all of those things and the reduction in operational and manual processes, that then reduces the cost and the risk of owning the service. So all of these, I'm sure you're all familiar with. But the question I think many customers still have is, if you do want to start to move many databases into Autonomous service, how do you go about choosing which databases, and how do you check whether those databases are really suitable for Autonomous? We are in a situation at the moment that nearly all databases can get to Autonomous Database. There's very few features which we don't fully support, and most of those are fairly minor and very old features. So all databases can go there, but depending on how old and how many of those older features you use, it might be slightly more complex to get to Autonomous. So what we're going to talk about in the next hour is about a tool that we have that allows you to be able to assess the complexity of moving to Autonomous and to identify those small number of things, hopefully, that you might need to change to get there. And then the second part of today will focus then on elastic resource pools, which are very, very new. They've only been around, I think, a few months. And the idea of those is to then support that large-scale consolidation of databases into Autonomous by giving a billing model which makes it extremely efficient and cost-effective to be able to move to Autonomous Database. Now, the tool we can describe, one of the great things from Oracle's point of view about this is that if you as customers wish to share the information about your database with us, that's an option for yourselves, then we can then, as Oracle, learn about your estate and learn about what we need to do to make Autonomous Database a much more relevant service for your needs. And so one of the things that we have found in looking at that data is that around 42% of databases, this is on a sample size of, I think, 5,000 or 6,000 databases from customers we've looked at, they only need 1 or 2 small changes to get to autonomous. So I think if any of you have tried autonomous maybe a few years ago, 3 or 4 years ago, there were a number of challenges that you would have to go to get to autonomous. But over the intervening period between then and now, the development teams have done some fantastic work in removing all of those differences. So now autonomous is very, very close to what you would experience in NX database deployment. And only a very small number of changes are made to be able to move a database, say, from 19C through into Autonomous Database. So the other thing that we're very aware of is as customers, as customers start to look at doing not just 1 or 2 migrations, but doing maybe hundreds of migrations to autonomous, that you will need to go through this sort of process. So the first thing that you do is you look at your estate and look at the databases that you have and decide how many of those are good candidates for OCI or for cloud in general, and then for autonomous databases. And then from your estate, you may select the databases that you are happy to go into cloud and to the various different service targets. But even when you've done that, you as customers will always need to prepare a business case. Nothing is free, so you must be able to show what the return on investment is over a long period of moving to autonomous. Now, as I mentioned at the beginning, the operational costs will reduce dramatically because of the level of automation in Autonomous Database. So those business cases are relatively straightforward and it can be quite compelling, but building the evidence to go into that business case can be challenging. So one of the other things that we're doing with the tool we're taking through is to provide that evidence for yourselves to be able to build a business case. And then as you get to the migrations themselves, it's all about planning those migrations, about prioritizing, about estimating the amount of work that needs to be done. And again, we have aspects of the tool which help that. And then finally, in performing the migrations themselves, as I mentioned, there are some small things that you might need to change. And so what the other thing that the tool gives is our lists of schema level changes that you would need to make your particular database compatible with Autonomous Database. So those are the sort of the 5 steps that we see most customers going through. And we're now just about to release version 3 of the Estate Explorer, which is what we're talking about today. And that really now goes right the way through all of those 5 stages and supports. It doesn't do the whole job, but it gives essential knowledge and information about your estate, about your databases, and about the changes that need to be made to go to autonomous. So, the first thing that we talked about there was all about understanding your existing estate, and that's a critical aspect of anybody's migration and consolidation into the cloud. And so the tool itself gives a set of quite unique visualizations, and we'll demo those, and Paul will take you through them a little bit later. But critically, it also places databases in both a technical and a business context. Very often through OEM, you might get a very technical context, and other systems you might have as customers may look at it more in a business context. But to make choices about what to take to autonomous, it needs to be both of those things together. So what we try to do in the tool is to allow you to build the business context, in other words, maybe which data center the database is in, or which geography, or then the technical context around the platform that the database runs upon, or the size of the database. So bringing those things together to allow you to have a holistic view of a database to decide whether it's appropriate for cloud and whether it's appropriate for autonomous specifically. We can also understand your resource uses and the servers underneath. And once you understand all of that and analyzed it, and you can then start to optimize your cloud migration plans. You start to think about the amount of effort. You can start to identify also related clusters of databases, so that you take databases which are closely related together at the same time to reduce the network bandwidth between on-premises and cloud. And as I mentioned earlier, you can also do that list of changes. So all of that is built into the tool. And the good news is that the tool is free and it's open. And we'll take you through into a little bit more detail about what that means in some later slides. So in terms of the capabilities of the tool, it can genuinely analyze thousands of databases in just a few hours. And we have had customers take the software from us to do this in the morning, and then they have completed hundreds of databases by the following day. So it's just possible to do very large numbers of databases very, very quickly. And those innovative visualizations are very new, and I hope you like them, but they give you a unique insight into your database estate from a connectivity point of view. And then the final one that I wanted to mention was that as customers, you don't want to give everybody in your organization access to this as a tool. It's an Apex app under the covers, but you don't want to manage all the permissions for hundreds of people maybe to look at that. So what we've built into the tool is a way to produce high quality PDF reports, which then can be shared around your organization. So if you're building a business case, or if you want to share with application owners and service owners, you can take these reports to them to have that internal conversation to build up knowledge of the databases and also help maybe persuade service owners to move to Autonomous. So we're trying to cover all of the bases, and the way that we build the tool is quite iterative. We try to do a release around about every quarter. And we are highly responsive to you as customers in terms of requirements. So when you do use it, and you find things that you would like to add to it, we're very, very keen to hear about those for you to feed them back to us. Now, we also are very aware that the data that you have about your databases is sometimes commercially sensitive, sometimes it's security sensitive. So we've also tried to make this tool as easy to use as possible, and to keep security people happy, and to keep privacy people happy, and to keep your commercial negotiations with Oracle secure as well. So we don't require you to share information with Oracle. I mentioned at the beginning that a lot of customers do share that, where they're happy for us to see their information. But if you prefer to keep it totally private to yourselves as customers, then there is no need to share any of that data with Oracle. And we've also made the tool as easy to install as possible, and you can put the tool itself on premises, you can put it in public cloud, you can put it on one of our competitor clouds, for example. It's even small enough that it can run on a laptop, and we have run it on a laptop ourselves. Our preferred installation target is actually Autonomous Database, and it installs very quickly. So if you already have a tenancy, you can install this very quickly in Autonomous Database and get all the benefits of that, all the ease of use. So it's also an ultra-light footprint. So we try to make those prerequisites for the install as few as possible. Basically, it's very standard Oracle tools like SQL Plus for the data extract, and then 19c with Oracle Apex and ORDS for the application aspect. And when we run the scripts, all the scripts run in a way that they don't leave any footprint behind. You don't have to install anything on your servers. It uses SQLnet to connect to the actual databases. So, and then it only runs anonymous PL SQL. So it doesn't create any procedures or functions, and it only needs to access those databases read-only. So I'll go into these a little bit more detail later, but it's a very, very light touch tool. We intend this to be used by both customers and partners. And if you are a partner on the call, please contact us, and we're quite happy for you to white label this to take it yourselves to customers. We are all about trying to make it as easy as possible for you to migrate your databases to the cloud. And the overall tool is relevant whether you're going to Autonomous, or in fact, whether you're going to Cloud service, for example, or in fact, customer at cloud. So there's features in here which give you that visualization and visibility regardless of your target. And the last part of this is that we try to also make the tool as parameterizable as possible. So if you have very specific things that are just for you as an individual customer, you can parameterize the way the tool works. And we'll come on to that a bit later as well. We'll share these links. So these are the external information. This code at the moment is still private to Oracle. We are happy to share the source code with you, and we find in many security organizations within your businesses will want to see the exact code that we run, and we're quite happy to do all of that. And so therefore we do make that all available together with the documentation. So in terms of running the tool itself, it really splits down into 5 stages. So the first thing is that you build a catalog of all of your databases that you have, and we can take that information from Enterprise Manager or from other configuration management tools. And then within the application, you can look at that business and technical context and select the databases that you want to do a much more detailed analysis on. And then you run a second set of extract scripts, which do that SQL connection to the target databases, that very light touch SQL connection. And that pulls the essential information that we need to build all the reports that we have within the tool. That enables you then to do the analysis of the databases that you have, and then to evaluate the results. And as part of all of that, you start to build groups of databases, which will eventually become groups of databases which you may wish to put into a particular tranche of a pilot or a longer term migration plan. So you probably can't read any of the details on these 5 slides. What I'm going to do now is I'm going to hand over to Paul, and Paul will give you a live demo of some sample data that we've built over time. And we'll show you the key aspects of this. So are you happy to take over, Paul?
Yeah, absolutely, Simon. Thank you very much. So hopefully you can all see the home screen of Oracle Estate Explorer. And what we're looking at here is what we call a number of catalogs. So those 6 rectangles on the screen are catalogs. They are, for example, lines of business inside an organization. So in this case, we've got a fictional insurance company. So we've got lines of business around life insurance, health insurance, pet insurance, etc. Those catalogs can be anything you like. So they could be technical, or they could be business, or you might just have one catalog for your entire organization. It's quite typical to have a single catalog for the whole organization. And in that catalog, you'll work with every database that you have. Okay, so the Estate Explorer essentially fulfills 2 main functions. The first part is to really explore and understand what it is that you've got. You can't really make a decision about what you want to do until you know exactly what it is that you're dealing with, or that you've inherited, or that has evolved over time. And then the second part of Estate Explorer is to then say, okay, once you've understood what it is that you've got, let's start analyzing and assessing those, and starting to prioritize those databases, maybe along a technical set of criteria, or maybe along a business set of criteria, or indeed both. So we're going to work within this catalog called My Demo Catalog, and you can see that I've got 416 databases in there, and I can see some basic metrics about some of the data that we've got. But the first thing I want to do is get the very highest level view of our database estate, and I do that by clicking on Estate View. And when I go into Estate View, I can see various, again, high-level metrics, such as how many unique hosts are my database deployed on, how many CPUs do they have, how many cores do they have, and then details about my databases, 416 of them. For 105 of those, I've done that detailed extract that Simon talked about, and I can see how many database cores there are, and the sizing at the very highest level for the entire estate. Now, if I scroll down here, this is quite an interesting view, because what we're looking at here is really a graph that shows all of the relationships between the databases in our estate. So these are all the database links across all of the databases in our estate, and we can start understanding where our dependencies are, and where there are points of complexity when it comes to migration. So, for example, if you were asked to pick a good candidate as your first database to move to Autonomous, you probably wouldn't want to pick this database here, which has potentially hundreds of dependencies, because if you move that, you might well have to move all of these as well in order to overcome any kind of latency issues or any kind of other dependencies. So it might be wiser, for instance, to focus on a smaller cluster of databases that are quite discrete and probably represent a specific function inside the organization. So at a single glance, we can start seeing, well, first of all, obviously, the complexity, but we can also start thinking about and how many databases would need to move if I move the centerpiece of any one of these clusters. So pretty useful information there. And I can click on any one of these, and I can get a downloadable list of those databases and their links. And underneath here, we have a full report as well, which again is completely downloadable. Okay, so that's the very highest level kind of view of our estate here. The next thing we might want to look at is the database catalog. And this is really all the high-level metadata about all of the databases in our estate. And the purpose of this screen is really for us to become more and more familiar with what it is that we've got. Remember, this data could have been pulled from multiple sources. Some of these databases could have come from Enterprise Manager or many Enterprise Manager repositories, as well as external data sources as well. But they can all be pulled together and get a single view of the entire estate. And you can see here, we've got some pretty interesting charts here about database type, database version and environment. And if I just expand here, you can see that actually I can create a chart on any one of the characteristics there that we might be interested in for our estate. So location, for example, and then I can add that chart to here, and that can be saved in the tool that'll be there next time that we go into there. And underneath here, then I can then see the list of all the databases in the estate. In this case, remember, there's 416 of them. If I just gently scroll across, you can see the kind of information that we're collecting here, information about the database itself, its version, the host that it runs on, CPUs that it runs on, how many cores, whether it's hyper-threaded. Hopefully you get the idea. But this is all really high-level stuff. I can also drill down. If I'm clicking on the database name, I can actually go into each individual database and have a look a little bit more about what it is that we have. So perhaps things around the database size, how much memory it's been allocated, how many cores, database cores, how many maximum concurrent sessions it's got, various options that are installed on the database, et cetera, et cetera. And so the idea then, as I said, is to get a really good understanding of what it is that we've got. And one of the ways in which you can share that understanding is by creating what we call a catalog report. So just by clicking on this button here, I can automatically get a report that we can share. You can share inside your organization around some of those characteristics that we've just looked at, the locations, etc., database versions, etc., all fully automated, downloadable as a PDF, and then shareable across the organization without people having to use the tool to actually talk about the estate. That's a pretty handy thing to have. Okay, so I've got a good understanding of my estate because I've looked at this information, I've been able to characterize it, and I've been able to create a few charts, etc. The next thing I want to be able to do is to start prioritizing that entire catalog into groups. So you can see here, I've already created 4 groups. I've got all 12C databases, all of my databases, so every database I have, all my development databases, and all my test databases. And as I said at the start, these can be grouped according to technical criteria, like the version, for instance, or the character set, or it could be along business criteria. It could be like, priority 1 applications, you get the idea. And it can be any combination of them. And a database can belong in more than one group simultaneously as well. So you can overlap the groups and you can separate them out as well and get very clear focus on what it is that you're looking at. So as I said, I've already got these existing groups. I'm going to create a new group here because, of course, the one that's missing here is our production databases. So I'll just create my group. I'll call it full production. All prod databases. And I've created my empty group. I now need to add my databases to that group. Okay, so here is where I can add those databases. So I'm just going to filter this report, and I'm just going to say where the environment, I can see DB environment equals production. Okay, so it brings me back all my production databases. I just tick this box at the top, it selects them all, and I can just add them to my OEE group. And if I come back out now to the groups, you'll see that I've got my 84 production databases all within that group. Okay, so now what can we do? Well, what we do is we want to find out which of those 84 databases are the most suitable or easy to move to Autonomous with a minimum amount of change. And the way that we do that is we apply a set of tests to those databases. And if I just show you those tests in our test catalog screen, you can see a whole list of them here. There's about 25, 26 of them. And they're all of the things that you would need to consider if you were going to move a database to Autonomous. And usually it's because the way that we have implemented one of these features has changed in Autonomous. So let's say database links, the way that you create a database link is very different, or somewhat different at least, inside Autonomous than it would be on premises. It's still the same database link under the covers, but the way that you create it, the way that you implement it is different. And so therefore you need to be aware of that. There are certain packages, particularly packages that are concerned with network-based functionality that are more restricted perhaps because they need to be, because it's a cloud environment. So there's a number of checks that we make, and even if a database is found to have one or more of these, it doesn't mean that that database can't move to Autonomous. As Simon said at the start, just about every database can. It's depends on how much effort would it take to get there for the benefits that you get through getting there. So these aren't, you don't pass or fail these tests so much as just there's more of a quantitative assessment about what's involved in resolving the issues that are found with these tests. You can also, I'll just point out here, you can actually create your own test as well. So you can add to this list with your own completely customized test. As long as you can write a bit of PL SQL, you can extend this test catalog. So in this case, we're going to run what we call a scenario, and a scenario is just a subset of these tests. So we have a scenario here, and there are 19 of those tests in there. You can see that the ones that are ticked. And what we can do is we can actually apply different weightings to the test. So not all tests are as much effort to resolve as others. And so you can change these completely to your own profile, really. So if you have certain skills in a certain area in plentiful supply, you might find resolving one of these tests easy. Whereas if you have different skills that are not, that you don't have the resources for, or are controlled outside your organization, that might be a more costly thing to remedy. Anyway, you can customize this to make it absolutely right for you. I'm going to go with our standard recommendation that we have here, and I'm going to run those tests against my all production group here. So I just click on this button here. You can see I've got 84 databases. I've got all the 84 detailed extracts. So I know that I can get a full run for this group, which is great. I'm going to run 19 tests, and I can see that I've not done this before, and because there's no previous executions. I'll run the scenario, and you'll see that literally within 2, 3, 4 seconds, the whole test will have run against all 84 databases, and I'll get my results. The great thing about that speed is I can iteratively fine-tune those weightings of the tests and make sure that they're accurate for me. It's not an expensive thing to run this kind of assessment. And the first thing that we see is when we run our assessment is this histogram. And basically what this is saying is databases on the left-hand side of this histogram are the easiest to move, and the ones on the right-hand side are hardest to move. Okay, so we can see we've got, out of our 84 databases, we can see that 59 of them have fallen into the easiest possible sort of bucket category here, which is 0. And then I have 9 in bucket 1 and 6 in bucket 2, and I've got a couple of databases in bucket 9. So immediately I know that I probably don't want to be looking at moving these ones first, not least of which because there's a lot over here and only a few outliers over here. But I need to know those outliers up front so that I can focus on those that are going to deliver the greatest value with the minimum amount of effort. Now, underneath that histogram, I can see a couple of pie charts. The first pie chart is showing me all of those tests that I detailed a moment ago and the relative cost of resolving the issues that those tests found. So you can see in this example, for this group, that I've got the most expensive test is actually addressing row ID columns within this group. And my second most expensive test is resolving database links. As I've said, it doesn't mean that these databases can't go to Autonomous, but there are things you may need to be aware of or that you may need to remedy in order to get ready for them to move. But the databases inside this bucket 0, the easier ones, probably have a lot lower effort. associated with them. And we can do that, but we can look at that by just clicking on this chart, and we can actually see within the easiest bucket, what are the things I need to look at there? Well, you can see by far and away, the greatest thing here is database links in bucket 0. And the great thing about database links is, as I've said, under the covers, they're exactly the same as they are on premises. So in actual fact, it's more of a redeployment of database links that are our challenge here, rather than us having to change, say, functionality within an application or something more complex like that. And then I can also look at the profiling, say, in bucket 9 at the more complex ones. And you can see here I've got index organized tables and row ID columns as being my more expensive tests that I need to resolve. I'll just deselect all of these. So I go back to the group level. 1 second. Click on here. Here. So this is the group level again. The second pie chart is showing me a count of all the things that were found by test. And the third chart is showing me the distribution of those tests across the different test types for all of our databases. If I click on something like row ID columns in the pie chart, I can also get some fairly useful information about how do I remediate row IDs. What do I need to do? Okay, you've told me about this. You've told me this is what I need to look at. How do I start going about that? And for every test that is applicable, we can get a starting point. Okay, so underneath all of this, I also have a list of every database, all 84 databases in the group. And I want you to focus on this DB remediation effort column, because this is the one that really counts. So these databases are ranked by how easy they are to move to autonomous. And anything with 0, of course, means nothing needs to change whatsoever. And as Simon said at the start, around about 42% of all databases need maybe just 1 or 2 changes to be able to go to autonomous. And there we're talking about things like redeploying a database link or something straightforward like that. And the next column, you can see all of the things that we might need to do. So these are the things that have been found, but they may not have a cost associated with them. So, for instance, if you think about basic lobs, for instance, lots of lobs use basic lobs as the file format. When you move to autonomous, they'll now become secure files. It's a change, but there's no effort on your part. But you still might want to be aware of that change for regression testing and things like that. I'll scroll down this list now. You can start seeing the numbers get a little bit higher, but really all of these, anything below, let's say 1,000, are really good candidates for autonomous. Once we start getting above 1,000, we might think about whether this is actually being a bit more complex and whether these are things we really want to look at right now. But what we can do as well is we can go into each individual database. Let's go on our worst performing one here, our most complex one, 6,120. And we can click on here and we can get the actual results for this database. So what are the issues that I would need to, if I want to read this database, what would I need to resolve? The left-hand pie chart is the calculated effort. The right-hand pie chart is the number of things that I would need to change, okay? And not only that, but if I wanted to know, okay, and what are my row ID columns, my 94 row ID columns, I can actually still go into here and actually get all of the offending articles, objects, whatever they might be, and start working directly with them. So within a few minutes here, I've gone from looking at my entire estate, remember that chart of clusters of databases, right down to looking at individual row IDs, row ID columns that I would need to resolve just in a couple of minutes. Okay, so it's really quick to go from a high level down to a low level. If I go back to my group assessment page, what's also great about this is, just like with the catalog, I have a group summary report. So I don't have to just stay within the tool. This could be exported as a PDF file, and all of the things we've just looked at, including that kind of league table of databases and the effort required to move them, is shareable across the organization. We talk about what the mathematics are behind this, or at least our logic behind what we do and how we do the assessment. And then we go down into each individual tests as well. So there's a lot of information that you can share, again, in your organization without them having to be attached to using the tool itself. And we also have a second report here, a group database report, which gives us actually a report on each and every individual database as well. So all 84 databases get their own report. I'm going to very quickly scroll to the bottom because the interesting ones, i.e. the more complex and difficult ones, tend to be towards the bottom. So here we can see for this database here, we've got the metadata about it, we've got the options, we've got its individualized result, and we've also got some text that's been generated to describe why this, in particular, this database became last in our ranking and what we would need to do. So what we're seeing here is a huge, proportion of that group that are really easy to move. Everything below 1,000, for instance, should be pretty easy to move. But we can also start looking at the more complex ones as well and fully understanding what would it take, what would we need to do in order to move those ones as well. Okay, with that, I'll hand back to Simon.
Thanks very much, Paul. And so what I thought I'd do now is that obviously we've been doing a lot of work with customers, and customers have been sharing their information with us. It's to just give you a little bit of an insight into what we have found. So this is one specific customer we worked with. We analyzed 388 of their databases, a mixture between 11G and 19C. And what we could see is that a huge number of those were 80%, in fact, were in that low effort category. So this particular set of databases is a really good candidate to do high level consolidation of large numbers of databases straight into Autonomous. So this is sort of typical of a medium or a medium-sized estate. Here's a bit of a larger estate. This is pretty complex. The customer themselves explained to us that they've included in this analysis every database they have, whether it be development through to production, well-maintained databases, old databases, and everything basically. But even within this, we saw that 65% of them were still in that low category. So I think what we have realized as Oracle is that Autonomous is not just a niche tool now. It is ready for taking very large numbers of databases from a consolidation point of view, with very, very few changes. And obviously, we as Oracle will continue to look at those moderate and the higher ones and try to add those features into Autonomous or make it easier to migrate them. But there are most customers in this one, half of these databases can go in very, very quickly. So that's around about 500, for example. The final thing I wanted to mention here was this is analyzing databases not on premises, but in Microsoft Azure. And because the customer themselves had migrated them to Azure previously, they'd gone through some level of consolidation and, if you like, cherry-picked the ones that are most applicable for cloud. So within that estate, we see an even higher number that are really ready for coming across into Autonomous very, very quickly. 30% of databases required 0 or 1 change, 88% in that low category. So it's worthwhile mentioning this because we don't really care where the database is. From our analysis perspective, it can be on premises, it can be in a hosted DBaaS service, it can be in a competitor cloud, it can be already in OCI in one of the other database services. As long as we can connect to it with SQLnet, then we're able to analyze that. So this is truly a hybrid cloud analysis tool which can look at databases anywhere. Now, it's great for us to talk about the consolidation, but that's only really relevant if the consolidation is cost effective for yourselves. So I'm really pleased that we have introduced the structure called elastic resource pools, because it makes a fundamental difference to the pricing and consolidation. And again, this was done with direct feedback from you as customers who told us that you really wanted us to make Autonomous Database a good target for consolidation, and we had to make it a really compelling option. I think you as customers tell us that the operational costs are very, very low, but you need the cost that you give to Oracle to be equally low. And so that's what we've done here. So what are elastic resource pools? The concept is relatively simple. You as a customer purchase a minimum set of eCPUs, and so you commit to 128 as the starting point. And then within there, you can put pretty much as many databases as you like. And when you allocate those eCPUs to the databases, you can build them up, not just up to the 128, but actually up to 4 times the number of eCPUs you've actually got allocated. So this isn't oversubscription as such, but it allows you to put the min and max on the Autonomous databases so that you can fit hundreds of databases into a single elastic resource pool, and you don't have that minimum 1 eCPU per database. So that this makes consolidation of either little used databases or infrequently used databases really, really effective. So what we tend to see is in the analysis that we've done, we are seeing that this is 4 to 8 times lower costs than without elastic resource pools, and that really changes Autonomous Database into an extremely compelling return on investment for large-scale consolidation. So as we hope you've seen in the previous slides, we think that Autonomous Database is ready for big-time consolidation, and we've seen many customers engage with us on this. And now we've put a commercial model around that to make it equally commercially compelling. You can see there at the bottom, I've got a list of things where it becomes very, very effective. So if you have very small databases where they're infrequently used, or maybe they are peaky databases which are only used 1 or 2 days a month, or maybe test and development services which are only active for part of a month. All of these are really, really good candidates for elastic resource pools, because they enable you to leverage that 4 times cost reduction. We're also seeing it with partners as well, who maybe supply in SaaS-based services where they deploy hundreds of very similar databases, and they may be quite infrequently used or very low transaction rates. Again, those are incredibly efficient, cost efficient within Autonomous Database Service. Here's one example. So without elastic resource pools, you would require 512 eCPUs, but with them, the same databases may be down as low as 128. So you can see that's where the 4x cost reduction actually comes from. So the way that this works is that you buy groups of databases in chunks. 128 is the starting point. And then if you need more than that, you go to 256. And if you need more than that, you go up to 512. Now, because this is a logical placement of the databases into the elastic resource pool, it means that it's very, very quick, and you don't need to physically move the data or the databases. So in effect, you can create a pool, you put a database into the pool, and it within the hour, it becomes allocated into that pool and is billed with that pool. And then you can remove it from the pool anytime you like. And again, it's the same sort of time scale as coming in and out. So you can genuinely move your databases in for certain periods and move them back out again. It's very, very fast and very, very straightforward. And as I mentioned earlier, the maximum you can put into a particular pool is 4 times the number of eCPUs that are allocated. The other thing that's worth mentioning is within the pool itself. So the pool itself can grow 128, 256, 512 eCPUs. But within the pool, the databases there can move between a minimum and a maximum eCPU usage with just simple manual scaling. So you just tell the database you want to allocate some more, and it grows to the maximum size or any point in between. So very quick, very straightforward, and extremely cost effective. There's a couple of really good blogs that describe all of this in more detail than I can in this quick session, and also a little bit of a white paper on how are those cost savings. So we'll put those into the chat in a moment as soon as I stop talking, and I think those are really good if you want to get a slightly more detailed introduction to what these elastic resource pools are. Now, I've talked a lot here about cost effectiveness of consolidation. And to support that, very shortly, we'll be releasing a new version of Estate Explorer, which goes way beyond just the support for the migration. And it supports building that business case by giving you actual numbers of cost savings that you will see through moving to autonomous. Now, as I mentioned right at the beginning, most of those cost savings are about reducing the amount of operational cost. In other words, reducing the number of database administrator hours, reducing system admin, reducing hardware, reducing all of those things, and putting them into a much more effective way of delivering those things, which is within the service itself. So within the tool, we got this return on investment calculator. It compares across on-premises, Exadata Cloud Service, and Autonomous. So you'll be able to look, and in fact, you'll be able to blend the targets. So for example, if you have 100 databases and you decide to 60 of them can go to Autonomous and 40 to Exadata, then we model that, but then you can change it to 40, 60 the other way, and Paul will demo that for us in a moment. And this will include the new version I mentioned of Estate Explorer, would include elastic resource pools, plus auto-scaling, the manual scripted scaling that I've just described, and also serverless and dedicated. So I'll stop talking about it now, and I'll give Paul maybe just a 5 or 6 minute quick demo about what that looks like.
Yeah, absolutely, Simon. So let's go back to our groups that we created a moment ago. We look at our all production group that we have inside Estate Explorer. Let's go back into the assessment screen. And this time I'm going to go into the TCO model. So what this is showing me on the left-hand side, left-hand chart, is showing the cost of running this specific group of 84 databases on-premises versus running it in Oracle Cloud. Okay, so it's driven from the data that we collect. Okay, all of the sizing calculations and the cost calculations are based upon the underlying data. It's not guesswork. It's actually empirical evidence of what things will cost. So in case you're wondering, on the on-premises side, where do we get that information from? Well, quite frankly, you provide it. So you tell us what it costs, for instance, to run a database for a DBA for a year, or a sysadmin for a year, or what you're paying for support for hardware. So all of these values that define the on-premises cost are completely adaptable to your situation. So we're not prescribing, we're not trying to inflate the on-premises side. We're basing this, we do give you some figures to start off with based upon our experience of obviously having worked with many customers in this field, but you can change these to be exactly what you want them to be, because the most important thing is that the model is credible, okay? So the on-premises side, of course, is determined by yourselves. The Oracle Cloud side, of course, is determined by us. So we'll size the underlying group of databases and determine what it will cost to run on Oracle Cloud. Now, at the moment, we're running this on, if you like, vanilla ADB serverless. Just if you move those databases to Autonomous today and did nothing else, what would it cost? Okay, and you can see the breakdown on the right-hand side here. You can see the majority of the savings for running on Autonomous, as Simon said, is on the operations side of things. And there's also, as Simon said, well, let's look at our histogram here of our effort. So I say, you know, but I just want to take a small slice of databases to run on Autonomous first. I might want to move more later, but let's say if I just took the top 20 databases, the 20 easiest databases, and move those to Autonomous, I could just move this slider here, and it will automatically, more or less in real time, recalculate what the TCO model is. It's still going because you can see the circles spinning around. Okay, so now what we're seeing is that it's still slightly cheaper than the on-premise version, but now we're running the easiest 20 databases on ADB serverless, and the remaining 64 databases we're running on Exadata. I can also fine-tune Exadata dedicated by using scripted scaling as well, and see what the cost reduction would be there. So that's all great, but let's supposing that, you know what, I'm pretty confident about Autonomous. I want this group to run all on Autonomous, so I'll take it back to where we were, so that we're now running everything back on ADB serverless again. I'll just wait for the TCO calculator to catch up with me. But what I also have here is I have the ability to select, as Simon pointed out, all the different models that you might want to consider. So you might want to consider auto-scaling, for instance. So I turn auto-scaling on, I can save quite a chunk of money just straight away with, you know, just by turning auto-scaling on, I save money, and very little effort involved in doing that. But also in this particular case, if I select elastic resource pools, I see that elastic resource pools are even more effective. And the reason being is that this particular group is a group of 84 databases that can be oversubscribed, that have relatively low utilization needs. And so therefore, essentially, I've consolidated them on a smaller underlying eCPU footprint. And therefore, I can get those kind of returns that Simon talked about, you know, 4 to 8 times or whatever, over running them in a non-consolidated form. And with that, I shall hand back to Simon.
Thanks, Paul. So I'm just going to go through a few slides very quickly now. We've only got a few minutes left. So in terms of the overall process, we talked about building a catalog, which You can either provide that catalog in a CSV file, or we can run a script against Enterprise Manager and it'll extract that CSV file. That CSV file is loaded up into the application, which you then build the groups and choose the databases that you want to go into for more detailed analysis. And that runs against those databases and produces another CSV file. You load that CSV file back up into the application, and then everything else is then done from there. So those are the 3 stages, really. Building the catalog. And as you can see, everything's open. There's no binary here. Everything is just CSV files, which your security guys or yourselves can look at to make sure that everything is fine and it's not taking any information that you don't want to share. So the database information is captured. As I mentioned, it's very lightweight. It's read-only. The scripts themselves are completely open, so you can read anything that you like, and there's no requirement to share the data with Oracle if you don't want to. So we state that we'll support 11.2.04 onwards. Some of the more detailed information is lacking in the older versions, but we pretty much will be able to support right the way through. We do recommend running it on a Linux host, but that can be just a virtual machine somewhere. In terms of the application install, that does need Oracle 19c, Apex, and ORDS. You can put it pretty much anywhere. I think I've mentioned this already. In a VM, on Autonomous Database, our favorite, but also any on-premises database that's 19c and Apex and ORDS, or in fact, any cloud. Now, we also, as Oracle, will help you run a State Explorer, and we've got 4 different ways of being able to support you. If you want to run it entirely on your own on-premises, then we can give you the code and we can give you some just some very brief support. But if you want to collaborate with us, our engineers will work with you as customers and guide you through using the tool and interpreting the data. But you run the extracts yourselves maybe, but we can support you in doing that. We do provide a service. Some customers who are very happy to share the data with us just run the scripts to gather the information, and then they send them back to us, and we will load them into an instance on a private Oracle tenancy and just give you the reports back. So a handful of customers who are maybe pushed for DBA resource work with us in that way. And then finally, we also work with partners, and a couple of partners are already white labeling this and are using it as part of their overall migration to cloud offering to customers. So those are the 4 ways that we tend to engage, or in fact any blend of those. But it's nice to think of it in 4 different levels. So in summary, then, what are the key takeaways that we'd like you to think about? This can genuinely analyze the entire database estate in just a few hours. We usually quote around 10 to 12 seconds per database. You can identify immediate cost savings. One of the things one of our customers found was that they had about 20% of their databases hadn't been turned on in months, but they were still paying DBA resource to maintain them. So they immediately culled that and immediately had some savings. So just that fact of being able to understand your estate a little bit better can help you identify some of those immediate cost savings. We took you in detail through maximizing the return on investment by choosing the best target service, which balances operational costs with the cost savings around autonomous. And then finally, don't forget that we provide information about the migration itself, giving you specific actions and guidance and advice about how to migrate to autonomous. So those are 4 main things we'd like you to take away for today. And I guess it's a big thank you to staying to the end for those of you who have stayed right until the end. It's always a pleasure talking to you. And I don't know, Marcus, if you have anything that's come up in the chat that you might want to highlight.
Thank you. Thank you very much. So guys, Q&A is open. We still see a few questions coming up. So thank you again, Simon and Paul, if you guys can take a look at those. Go ahead.
So what just to interrupt, Marcus, one that I think is worthwhile mentioning is about the resource pools. They have been there since September, so they are ready to use today, so you can go and do that. For the State Explorer, we'll have support for that imminently. I'm hoping to certainly before Christmas. So those 2 things will map on. But yeah, the pool's been available since September.
Excellent. That's great.
I think that's it. Thanks very much, Marcus.
All right. Thank you, guys. So as always, again, I'll have the links for you guys to so that you guys can basically use these links. I'll have them in the documentation and where we have our recordings as well. And then again, if you go back to the Learning Lounge, you're going to see the links there and all that information. Okay. So I'll leave the call open for now. If there's any more questions, you guys can just type them in. I already see them, one coming up. So, Simon and Paul are going to be able to write and answer the questions there together with the other folks from the teams here. And thank you again, guys, and see you guys in a couple of weeks.